Okay, next we have about creating interactive websites. So we have Ethan here, our vision engineer. So he is going to introduce us about streamlit. Ethan, please.
Introduction, and I'm very honored to be accepted to the talk today. So today I'm going to introduce to you Streamlit, which is a library for us to create interactive websites easily. And before we start, I would like to introduce myself. I am a computer vision engineer in Sabbath Company Limited. Sabbath is a startup company in Hong Kong Science Park, and we are focusing on AI, computer vision, and 3D visualization. My day-to-day work includes, but not limited to, developing computer vision solutions and implement it in Edge AI devices. So Edge AI devices are shown on the right-hand side. These are NVIDIA's Jetson series. So they are specialized for doing AI inferencing. For my education background, I have a bachelor in physics, and I'm from CUHK. And I focus on theoretical and computational physics. So that's all about myself. Let's get started. For me, I think there's always stereotypical Python developers. We love data science. We love training models. We love doing cool data visualizations. But when it comes to interacting with your client, or you want to show your project or cool visualizations to your friends and family, the best way or the most straightforward way is to build a web application. But this process could be excruciating. Like, it's very sad because you're basically doing full stack development. You need to take care of the front end design, the back end design, API design, connecting things here and there. So it takes a lot of time to train the models and do the data and analysis. You could take the same amount of time or even more to learn about how to develop webs. So one day I came across with the library Streamlit. It claims to be a faster way to build and share data app, and it could turn data scripts into a shareable web apps in minutes, all in pure Python, and no front-end experience required. So this immediately caught my attention, and I decided I need to dig deeper into it to see if these buzzwords are what it really says to be. But learning a new library could be quite puzzling because there are a lot of different APIs and you need to read through a lot of documentations. So today I hope to give a gentle introduction of Streamlit using a few examples. Firstly, go through the basics, and then I will develop an interactive data app, and lastly, I will showcase a video analytic app. So Streamlit provides a hardware example, which is very easy. The first thing you need to do is obviously install Streamlit using pip. Pip is a package manager, Python's package manager. It helps you install, manage, and upgrade your third-party libraries. After installing, you just need to type streamlit hello, and then it will show and go to the port, localhost port 8501. So this demo mostly is related about data visualization, so I won't go through them in detail because it's very simple, and the codes are available in each of the demo. But after I try out the demo, the first thing that came to my mind is not about doing data visualization, but to build a personal website. Because that's the first thing you do when you are learning web development, right? So, and given that Streamlit is so easy to use, I think it is a good starting point. And I searched on YouTube and see that there is really someone giving a tutorial on how to build a website, and it's only 12 minutes. So I borrowed his template and built my own personal website, and this is the easiest personal page I've ever built, comparing to like JavaScript or even HTML. So I hope today I will give you a demo, like give you a peek on how it looks like. The run command is very easy. So it's just streamlit-run app. And I will use Google Chrome because I think Google Chrome is more common to everyone. Okay, so this is how my personal page looks like. You can see the page is by default responsive, so you don't need to do anything, you just need to use their APIs, and then you can directly have a responsive web page. And yeah, so there are some titles, some fonts, videos, and some projects I have done during my free time, and some pictures. Okay, so a very basic personal page. So maybe I will slightly go through the details. So first of all, the Streamlit set page config, it helps you to set the description on the tab. And then, so you can set icons and description. And next, the first API that is important is the container. Container is basically acting like a div in HTML. So it helps you to pack the things together into into one space. So here I'm packing my titles, subheaders into a space, like here, shown. And the next important concept is columns. So this helps you to split your container, split your space into n portions. Helps you to lay out your website. And for example here, I have left column and right column. So the left column will be some text, and the right column will be video. And Streamlit allows you to take in different types of videos. For example, you can have video file, you can have YouTube links, and a list of NumPy arrays. And the video is playable, just like that. And moving on, the columns could also be customized on different ratios, for example, 1:2 ratio and 2:3 ratio. So you can see the website is really 1:2 portion, 2:3. And lastly, the third column will be having three spaces. And here I would also like to go through another important concept, which is called cache data. So basically this function is loading all the images in the images directory, and it will it will be loaded into a dictionary, so it could be displayed on the screen. And here we use a special decorator, cache data. So this is an important feature in Streamlit that helps you cache the return of a function. So for example, if you have some heavy data processing functions, you don't need to rerun it every time the user refresh the page or another section. So it could help improve the user friendliness. So here I just use it to load image. So every section it will just return the cache. And moving on, the second demo will be about an interactive data app. So I do a very simple Monte-Carlo simulation on stock market. So it's using, the page looks like this. It has a form that allows you to configure your simulation, and after you run the simulation, you will have results, a line chart, and some distribution pipelines. And an important disclaimer, this is not financial advice. So yeah, Monte-Carlo simulation is a very toy model. Toy model means it won't work in real life. Yeah, so it's just a demo. Maybe I'll quickly show it to you guys. Here you can see that I could paste a very nice equation here. So Streamlit allows us to directly translate the latex formulas and show onto the web page. So this could be very helpful for those who are doing scientific projects or math-related projects. And this is a stochastic differential equation. And you can see from the code, it directly translates the latex formula. And for the form here, it's a very common feature in a web app to have a form, so you can take in text input or numbers input. Here I used Streamlit default number inputs, a slider, and toggle file uploader. So here, for example, is it too small? I use it to configure my simulation. For example, how many number of random walkers, how many steps I want to forecast, how many number of trajectories to plot, and the value at risk, whether I want to use GPU to accelerate this process. And here I have a file uploader. So I could upload, for example, Apple's stock data, which is from Yahoo Finance. And Streamlit allows us to easily display pandas data frame. You can see there's a year of financial data. Okay. And then we could directly start. So after a simulation, I used a line chart to plot the trajectories. Is also an API available in Streamlit, which you can directly call and put in the data. And pyplot is also available, so you can directly return the figures from matplotlib and directly output it onto the Streamlit. And here the conclusion. So the conclusion for Monte-Carlo Simulation is basically modeling the worst chances. The worst chances of losing how many from your original profile. For example, here I set a 95% value at risk, so you have the worst 5% chance of losing around 10% of your profile. So, okay, here I also want to show you guys using GPU to accelerate the process, because Monte-Carlo simulations are independent of each other, each random walker. So you could use GPUs to parallelize this process, which will make it much faster. Before we are using CPU, so it's 1.5 seconds. If we use GPU, we will achieve a much faster rate. And this will scale up if we have larger number of random walkers, of course. Yep. Okay, so these are the two demos. So after these two demos, I think I'll go through most of the APIs available in Streamlit that I think could allow you to build a lot of interesting apps already. But as I am from computer vision background, I'd also like to give some examples related to video analytic application. So the first one is having an object detection application on edge AI device. So as I mentioned, edge AI devices are like this. I bring it today. So this is, So this is a Jetson Nano. It's very small, and today we use it with a USB camera. So the USB camera acts as the video source to take in the images. Okay. And for the model, I used MobileNet V2. MobileNet is a very popular pre-trained model in the industry because its accuracy is okay, but it's not a very heavy model. So it has a good balance between accuracy and also the performance. And the library I use today is Jetson Inference, which will do the object detection for us. And then for displaying the result, I used Streamlit to display it onto the web app. And the whole code is just around 30 lines. So it's extremely simple and straightforward. And okay, I would also like to give a brief introduction about Jetson Nano. So as mentioned, Jetson Nano is an entry-level edge device. It's quite cheap, and because of its price, it's being used in many STEM projects. But it is a hardware-accelerated device specifically for AI detections and video processing. So it's very fast comparing to CPUs, using CPUs to run models. Besides that, it has a very low power consumption, think it only uses around 20 watts power, and it has a small form factor. So as you can see, it's just the size of my hand. It's being widely used in some AI IoT projects. For Jetson Inference, it's an open source computer vision library for NVIDIA Jetson platform. So it's being used across, for example, Jetson Nano, Jetson Ori, Jetson Xavier. And the library provides a lot of pre-trained models and sample codes for people to use. For example, doing image classification, object detection, and segmentation. And it has an active community, meaning if you have questions, contributors will answer you promptly. And it is also up to date with the latest NVIDIA hardwares and softwares. For example, the latest Orange series and the latest Jetpack versions. So, yeah. And today I think I don't have enough time to really set up and do a live demo, but I have recorded a video about the whole process. So I'll play it. It's slightly blurry. So first of all, I need to build the Docker image for it. So Docker is just a tool for us to containerize all our dependencies. And then, because I have already built it before, so it has built cache. And then I just start the container with command. It will mount the necessary stuff. For example, mounting the video source. And the first thing I do in the container is just download the pre-trained models. And here it's all done, it's all provided by Jetson Inference. And I'm deselecting other models because we will only use MobileNet for this demo. To illustrate that, Jetson Inference has a lot of different models and sample code available for you to try, and it's quite fun. So after downloading model, I'm checking whether it's successful. I mounted the whole network directory because if you rerun, you would not need to re-download again. So I'm just checking if it is there. After that, I directly start the streamlit code. And when we visit the website, so here the IP is not my local host, but it's the Jetson's IP address. And it's starting to load up the pre-trained model. And you can see that it's printing out some TensorRT logs here. And this process could take up to 5 minutes. It's actually trying to compile weight file because the model file is a generic format across different platforms. But you need to compile it to an engine file for it specifically running on the Jetson Nano. So this will be optimized for the architecture on the Jetson Nano. If you take the engine file and run on your DGPU or other series, it will not run. So I've skipped that part, and here you see that I'm trying my very best to show you the demo works. So the model really correctly detects me as a person, obviously. And yeah, I keep on refreshing the page because here I'm illustrating another concept on Streamlit, which is the cache resources. This will help make the resources below, the models and also the video source, a global instance. So it will be shared across different reruns, and so that I could keep on refresh, but without any lag time. Let's see here. Okay. So I could give you a sneak peek on how what is the code. Oh, sorry. So it's really just 30 lines of code. It's very basic. It's just taking the image from the video source, from the camera, and then putting the buffer into the detector, and then returning the image into the Streamlit's image API. So this demo is very straightforward and very easy. It might suit the use case of edge devices. Sorry. It may suit the use cases of edge devices because it's doing the detection on the device and it has specific video sources. But sometimes you will want the users to be able to do detections on their web cameras. So you need another library. And this is an amazing work by another developer, which is Mr. Whitfix. I'm not sure if I pronounced his name correctly. It's using a library called streamlit-webrtc. So it allows you to stream your video and audio stream back over the internet and to the server to do inference. And apparently he's also a speaker in PyCon in Japan. So he has a lot of extensive examples on how to use this library. For example, it has object detection and semantic segmentation. So the difference will be it will stream from your web camera over the internet and back to the video server. I've also prepared two examples, very quick examples, to illustrate how straightforward it is. The first one is through using OpenCV, Fast Cascade model. It's a face and eyes detection model. And I'm using Emma Watson to do the detection because apparently, it could not detect my face. So I guess it's a pretty face detector. And not pretty enough.
No, I think it's just the camera. I think you just need a little bit of ring light in front of you.
Really?
Yeah.
Oh, I need to put a light on shine light on my face. Right?
Yes.
I will try it at home. Okay, the second example is Jetson inference again, but this time is slightly sloppy because I am transferring the data from my web camera on my MacBook and transferring through the internet onto the Jetson Nano. So you can see the result is slightly lag comparing to the first example, but it could still correctly detecting me as a person. So, okay. And in this example, I also, I think you cannot see it clearly. I also have a GPU usage below, which is using Jetson stats to monitor the GPU usage. Okay. Let's continue. So after all these examples, you may wonder, so how can we really deploy it to be production ready and usable for other people? Streamlit provides two standard ways. First, it's through their community cloud. It will deploy on their server so that everyone can view it. But it will require admin permission of your repo, so this might not be a correct choice if you have a private repository. So if it's private, the only choice you have is maybe through some DevOps tools like Docker and Kubernetes. For example, their Docker example is very simple. I've looked through the Docker file, and it's basically wrapping your Streamlit app into the Docker file, into a Docker image. So the Streamlit run command is still here, and yes, this is basically how it meant to deploy it. So let's summarize. Today, so Streamlit is an open source Python framework that I think it simplifies our web development process, so it will be easier for backend developers or machine learning engineers to make an interesting web app. I think the pros, in my opinion, are it's simple. You can focus on your data and your logic instead of wasting time learning how to do CSS, JS, and HTML if you don't enjoy those process. And you can directly have a responsive web application. It's interactive. The components and the widgets in Streamlit is able to take in user inputs. And then the community is also growing. There are more and more plugins available. in the community. For example, the streamlit-webrtc is also developed by the community. And I've also not shown many other potentials of Streamlit, for example, the chat APIs. So many large language models could use Streamlit to illustrate or interact with their clients. But for the cons, in my opinion, I think Streamlit also has a lot of magic because it's simple, right? So it balances out, you have less control over the web design. And it will make a harder time for you to debug as well if you face any. And also the production readiness. I'm not because of its limited deployment options, and it's different from the JavaScript way we're used to, which is compiling a build and serving the static file. But nonetheless, I think Streamlit is a fun library to try out, and I think you will have fun when you are doing it. Before we go, I would like to give a thanks for Mr. Scotty Kwok, because he actually lent the nano to me so that I could try out Jazz Inference and give this talk. He's being very supportive to me. And also Mr. Dominic Chen, he helped build the Docker file, which saved a lot of time. So yeah, thank you very much. And this is the Q&A section.
Questions from the floor? Do we have any questions?
So thank you for delivering this great talk, and now I can see the full potential of Streamlit. So what I want to ask is like, because now we are running the Python backend and Streamlit is serving the JS and the frontend, right? So actually, is there any chance that we can use some concurrency in Python, like using thread, so that we can stimulate true concurrency in the front end? Because you know in JS we only run a single thread, right?
Thank you for your question. It's quite tough. I think I also came across with this question because I want to do multi-threading in my demo, but I don't have time to take a deeper look. So I saw some forums and they are discussing about multi-threading. I see them using the context on Streamlit, so you can set the page context or something. So I think through those contexts you can return, or you can configure some, so basically manage different threads through the web, through the context. Personally, I haven't tried out, so maybe I will try out something. Thank you.
Thank you. Do we have another question from the floor?
I can just yell at Sure. How did you find Streamlit? There's a lot of static site generators and things. Like, how did you stumble upon it?
Actually, I'm just randomly scrolling Medium, so I found someone doing Streamlit and I clicked into it, and I see it's quite simple. So I think the guys are doing some data dashboards, and it's really cool. And I decided I need to give it a try.
Thank you very much, Ethan. So thank you very much, Walter, for interesting talk sharing. And our next session would be in 10 minutes. That would be 11:40. So if you stay here for PyScript, or you can go upstairs, go downstairs, and then go upstairs, take a lift to the 10th floor for Polar versus Pandas. So it's Polar versus Panda upstairs, and stay here for PyScript. Thank you very much.